Hi and welcome to today's session on scatter graphs. So scatter graphs are literally the way that they sound. What we've got is a graph with lots of points scattered about after we've gone and plotted them. And what we're actually trying to do, we're trying to look for some kind of pattern or trend. So what these graphs actually do, they take two variables and actually compare these, trying to find the pattern. So for example, here we've got some intervals, some class intervals. So age ranges from 10 to 15 years old, 15 to 20 years old, and the amount of hours gaming per week that they do. So on our graph, what we've got is just standard graph with our age as our horizontal axis and hours of gaming as our vertical axis. And we're just literally going to plot all of these points. So between 10 and 15, we've chosen the midpoint of this and we've put across at 30. Between 15 and 20, we've chosen the midpoint and we've put across at 45, and so on and so forth. So we've gone and created a scatter graph from this. Now, as you can sort of see from this, I've added this line of best fit into here just to highlight that as one variable is increasing, the other is decreasing, and this is known as a negative correlation. So we're looking for a diagonal sort of pattern heading from the top left to the bottom right. So the three different types of correlation that we've got the positive correlation. So as one increases, so does the other. So we're from the bottom left to the top right. Negative correlation we just see, as one increases, the other decreases. And we've got no correlation at all, in which case there's no pattern whatsoever or no visible pattern to the points that have been plotted. Correlations can also be weak or strong, depending on the type of problem which you've got. So we can actually use lines of best fit to highlight trends or patterns. So for here we've got lots of points all marked, and we've got a line heading from the bottom left to the top right, which highlights that this is a positive correlation. Now, as you can see, it doesn't pass through every point, it doesn't need to, but there should be hopefully an equal number on either side of this this line to try and highlight that it is the line of best fit. So things that we need to ensure of when we are creating our line of best fit, it doesn't have to pass through the origin, through 0, 0. For the most accurate line of best fit, it should pass through the mean of our two variables. So pass through the very center point. And any estimates made from the line of best fit must be made only within our data range, so within what we can see. So we can use this to predict or estimate solutions. Here we've got a graph where it's life expectancy depending on the number of cigarettes smoked per week, and we are looking to try and find an estimate for life expectancy of someone who smokes 60 cigarettes a week. So first thing that we need is a line of best fit. Next thing that we need to do is look for our 60 cigarettes per week. Number of cigarettes is our horizontal, so we draw a line going straight up from 60 up to our line of best fit, and then we draw a line horizontally to our vertical axis to give us our estimate against 60 cigarettes per week, and this will be 60 years. If you like what you see, please subscribe. Thank you very much for watching.